The second semester begins in the third quarter with our unit on thermochemistry and kinetic theory. The material in this unit is covered in chapters 10 and 11. Thermochemistry really is all about heat flow. When a reaction absorbs heat, as we see here, or is written as a reactant on the left side of a reaction, it's considered to be an endothermic reaction. However, when a reaction releases heat, as we see here, or is written as a product on the right-hand side of the equation, then it's considered an exothermic reaction. So in number 57, they want us to draw an energy diagram or a graph that shows an exothermic reaction. Since the definition of an exothermic reaction is a reaction that releases heat, then we have to start with reactants at a higher energy level than what they end up as products. Energy is being released. So the products that we finish with have less energy or heat than the reactants that we started with. There's some temperature conversions here with number 58 and 59. Number 60 through 62 all have to do with this idea of heat flow. If we're trying to calculate how much heat is going to be absorbed or released by a substance, we can use the equation Q is equal to M times C times delta T. So here, the value for Q, or the amount of heat that's going to be absorbed by this piece of aluminum, is its mass, which is 5 grams, times its specific heat capacity, which is given here, 0.9 joules per gram per degree Celsius, times delta T, which is the change in temperature. Since the aluminum is going from 20 degrees to 40 degrees, then its temperature needs to change by 20 degrees, and that's our delta T. That would be 20 degrees right there. When you multiply it all out, you get 90 joules of heat. As you look at the graph here in number 66, we'll just explain what's going on here. As a substance is absorbing heat, which in this graph we know it's absorbing heat because the temperature is increasing as you go from the initial part of the graph to the end. So as it's absorbing heat, it's starting out at point A here at a relatively low temperature. And as it absorbs heat, the temperature is increasing. So it's a solid. Here it would be frozen. It's at a low temperature. And it's a solid. As we move up this line, eventually at point B, it begins to melt. And it continues to melt into a liquid until you get here to point C. At that point, it would be completely melted. It's all a liquid. And then as this substance continues to absorb heat, it moves up this line, and that liquid would be getting warmer and warmer and warmer until you get to point D, where it would begin to boil or vaporize. And it would begin to boil and vaporize and continue to do so until it got to point E. At that point, there would be no liquid left, and it would be all converted to gas. And then past point E, that gas would just continue to get hotter and hotter.